right, we are back for the 3.5 video lesson. And guys, today what we're going to do is we're going to use your previous knowledge of slope and slope of lines. You guys remember slope? Okay. And we're going to use that slope to determine whether or not we have lines that are parallel, lines that are perpendicular, or maybe lines that are neither parallel nor perpendicular. Okay, so before we do that though, we're going to review some things about slope and make sure that you remember these things. So let's go take a look. So first and foremost, guys, do you remember that slope is represented by the little m, right? Little letter m. And slope represents the rate of change between any 2 points on a line. Okay, now, some of you, when I said the word slope, some of you thought rise over run. Others of you thought about the slope formula. Others of you might even have said, oh, slope. And you said, you know what? Y equals mx plus b. Hey guys, we're going to get to that in the next lesson. That's actually for the equation of a line. Okay, so when we're dealing with slope, all we're dealing with is the letter m. Okay, so how do I know when to use what? Okay, so guys, whenever you have a graph that has a line on it, you can always use rise over run. Okay, now, when you have a line on a graph, or when you're just given 2 coordinate points, you can use the slope formula. So you can always use the slope formula, but okay, you can use rise over run when you have a graph. Okay, now, as a refresher, guys, let's go and look at, do you guys remember negative slope, positive slopes, all of those, right? Okay, so negative slope. Guys, negative slope goes down to the right, okay? So you might write this down. It goes down to the right, okay? Positive slope goes up to the right, okay? Zero slope is horizontal, meaning that it does not go up nor down, okay? So it does not up or down. And undefined slope is vertical, meaning that it does not go, okay? It does not go left or right, okay? And guys, I know my handwriting is atrocious. I'm sorry. This is probably why I didn't go do so well in grade school and handwriting. Yeah, sorry guys. Okay, so you're going to need to remember negative slope, positive slope, zero slope, and undefined slope because we're going to use those types of slopes to help us determine slopes of parallel lines and perpendicular lines. Okay, so let's go take a look. Slopes of parallel lines. And some of you may already remember this. Slopes of parallel lines are the same. They have the exact same slope. So we would say that the slope of line 1 equals the slope of line 2. Okay? So if the slope of line 1 is 1/2, then the slope of line 2 is also going to be 1/2. Okay? So parallel lines will always, always, always have the same slope. Now, slopes of perpendicular lines. Okay, so guys, this one is a little bit different. Slopes of perpendicular lines have what we call negative reciprocal slopes. Some of you may remember that, okay? So that says that if I take the slope of line 1 times the slope of line 2, then the product will be -1. That's how you can test it, okay? Now, there's another way that I like to think about perpendicular lines, okay? So, negative reciprocal means this, okay? Negative means you change the sign, okay? So you're going to change the sign, and then you are going to flip it, which means you're going to do the reciprocal, okay? Now, as a reminder, guys, right here, horizontal lines have a slope of 0 and vertical lines have a slope of undefined. And guys, those are going to be perpendicular, right? Okay, something else that I want to point out to you guys, okay? Always, always, always reduce your slopes to a fraction or a whole number, okay? Reduce your slopes. So if I come over here and I look at the example that's in this picture, I've got that the slope of line 1 is a +3. The slope of line 2 is a negative 1/3. So I want you guys to notice we changed the sign. It went from a positive slope to a negative slope. And we flipped it, because isn't this the same thing as saying positive 3/1? Yes. And when we flip it, it ends up being 1/3, and we change the sign so it's negative. So these are some examples of how we're going to use the slopes, and we're going to determine if we have parallel lines, perpendicular lines, or maybe we don't have either type of lines. Okay, you know what, guys? We're going to go next, and I'm actually going to work out an algebra review problem with you. I'm going to do letter D with you. So let's go down to letter D, okay? Go down to letter D, and we look at this algebra problem. Now, on this particular algebra problem, if you notice, we have a fraction, but our variable is in the denominator. Hey, guys, don't let that freak you out. We got this. You ready? We still need to combine like terms. So that means that, guys, we still got to get this right here with the V. We still have to get it all by itself. So that means that I need to subtract or add, as the case may be, 3 to either side. I need to get rid of that 3. So I'm going to end up with 7/V equals, and when I do 11 plus 3, that gives me 14. Okay, you guys remember, I've said this before in a couple of the other videos, that when you have a fraction equal to a whole number, oh yeah, put the whole number over 1 and cross multiply, right? Okay, so let's cross multiply. First of all, I'm going to have 14 times V, which is 14V, equals, and then 7 times 1 is 7. And now, guys, you go and work out that algebra, right? We divide both sides by 14, and when we do that, V ends up being 7 divided by 14. When we reduce that, it ends up that it is 1/2. So V is 1/2. Now, guys, this goes back to what I said. Remember, we're going to reduce our slopes. Our slopes are rise over run, so we would reduce, if we have 7/14, reduce it to 1/2. Okay? Now, look, that variable in the denominator wasn't too scary, was it? All right, so ladies and gents, I tell you what, let's go down and let's take a look at, I think I want to do number 8 next. Let's go take a look at number 8. Okay, down here at number 8. We need to read the instructions. It says, triangle LMN has vertices at L, 0, 6, M, 5, 8, N, 4, -1. Determine whether or not the triangle is a right triangle. All right. So show all work, including our formulas, and explain our reasonings. So first of all, I have to ask you guys this. If we do have a right triangle, what must be true? Okay, let's see if you guys remember this. A right triangle has to have, and let me see, make sure I get this, okay, a 90-degree angle, right? So if it has a 90-degree angle, well then 2 of our sides must intersect, oh yeah, they must be perpendicular. Oh, and if we're asked to find the slope, then we can use the slope to tell whether or not we have 2 lines that are perpendicular. Okay, well, let's give it a try. Okay, so first thing you're going to do, okay, write down your formula. So we don't have a graph here, so we're going to need to use our formula, which is y2 minus y1 over x2 minus x1. Now, I wrote down an expression, but it's not a formula unless I put m equals. Okay, that's the slope equals. Okay, we're going to use the slope, and let's go. The slope of LM. Okay, so when I'm working out the slope of LM, I'm going to look just at L and M up here. And what I'm going to do is I'm going to label my points x1, y1, x2, y2. All right, so I have x1, y1, x2, y2. Okay, and now we're going to go in and let's plug it into the formula. Okay, so I have that slope equals, all right, y2 is 8 minus my y1, which is 6. Okay, and then I do my x2, which is 0, minus my y1, or excuse me, my x2, which is 5. My brain got ahead of my mouth, you guys. Okay, my x2, which is 5, minus my x1, which is 0. Okay, now we can simplify. Okay, so m equals 8 minus 6 is 2, and 5 minus 0 is 5. Okay, now, can I reduce 2/5 any more? Can I get that any more reduced? No, I can't. That's it. Okay, so the slope of LM is 2/5. And notice that it is a positive 2/5. Okay? All right, now we're going to find MN. Okay, so on MN, if you guys notice, we need to redo our X1, Y1s because now we're dealing with a different set of numbers. Okay? All right, so I'm going to help you label the X1, Y1s, the X2, Y2s, and then I want you guys to figure out the slopes. Okay, so I'm going to make M my first variable. Okay, let me get this. X1, X2. Oh, what did I just do wrong right there? Can somebody tell me? Okay, hopefully you guys noticed, hey, Miss Smith, that's supposed to be X1, Y1. How many of you guys make that mistake too? Yes, it is a common mistake. Okay, that is exactly why I did it. Okay, so make sure you slow down, right? X1, Y1, X2, Y2. Okay, oh, I accidentally changed colors on you guys. X2, Y2. Okay, now that I've labeled the X's, I want you guys to go find the slope of MN and tell me, what do you guys get? Okay, how'd you do? Okay, you should have gotten that the slope was 9. Okay, so if you did not get that the slope is 9, please look at my work, compare it to your work, try to see where you made the mistake and fix it. And it's okay. Guys, we want you to make mistakes because that's how you learn, right? Okay? All right, now, the slope of LN. The slope of LN. We're going to have to start over with our X1, Y1s all over again because this time, for the slope of LN, I'm not going to help you guys label anything. Okay, I want you guys to go find the slope of LN and tell me what you get. Oh, you guys are already done? Oh, look at you guys go. Okay, first and foremost, make sure you labeled your X1, Y1s. Okay, and let's see if I fill this in right here. Man, you guys are fast. I was still working out the problem. All right, so M equals, I got -7 over +4. So my slope is negative. The whole slope is negative. If one, either the top or the bottom, if one of those is negative, the whole slope is negative. So -7/4. All right, how'd you guys do? All right, hopefully you're on track. If not, make sure you take a look at my work, compare it to yours. Now, guys, now we have to determine, are any of these slopes negative reciprocals of each other, and will they form a perpendicular line? So one way to work this out is to test it. So when I test it, I can take 2/5 times 9/1 because this is my slope for LM and then my slope for MN. I'm going to multiply those and I'm going to see, do they equal a -1? Okay, let's see. Do they equal a -1? All right, so let's test it. Well, right here, 2 times 9 is 18. I multiply straight across. 5 times 1 is 5. Nope, that doesn't work. Those two lines are not negative reciprocals. Okay, all right. Well, let's try another one. Let's try MN times LN. And let's see, we've got 9/1 times -7/4. And that's going to equal, well, 9 times -7 is -63/4. Nope, that doesn't work either, does it? Okay, so let's see. The only other option is between LM and LN. So what do you guys think? The slopes between LM and LN, are those negative reciprocal slopes? Nope, those aren't negative reciprocal slopes either. Because if I took 2/5 times negative 7/4, right? That equals negative 14 over 20. Nope, that doesn't work either. So, do we have a right triangle? Do we have a 90-degree angle with some perpendicular lines? And the answer is no, we do not. Okay, and the main reason is because we do not have, there are not any negative reciprocal slopes, and I'm going to abbreviate, okay? There are not any negative reciprocal slopes, so we do not have a right triangle. Look at that, guys. We didn't even have to graph it. All we needed to know was what the coordinate of the points were, and we can figure it out with the slopes and tell you whether or not it's a right triangle or not. That's pretty cool, isn't it? Ah, yeah, I know. I'm a geek. I'm a nerd. I know. I get it. Okay, let's go down. And guys, let me see here. You know what? We're going to do number 10. Let's go to the next page and do number 10 together. And I can still be a geek, right? All right, I'm still going to be a geek. I can't get rid of that. That's just part of me, right? Okay, yay, you guys still like me. Okay. Let's get to it, Miss Smith. All right, so guys, right here in numbers 10 through 13, you're going to determine whether the lines that go through the given points are parallel, perpendicular, or neither. And then you have to explain your reasoning. So you're going to have to justify your answer. Okay, so, well, let's see. For number 10, it gives us line 1 and line 2 points, doesn't it? It gives us those 2 points. That means that if I have the coordinates, I can use the slope formula to find the slope. Okay, so, guys, if I were you, I would come over here. Oh, Miss Smith, you got to use the right type of pen. Come over here and write your equation for slope. Okay, x2 minus x1. Okay, and then we're going to find the slope of each of those lines. Okay, so I'm going to do the slope of line 1. Okay, the slope of line 1, I've got x1, y1, x2, y2. All right, so I've got the m of slope 1, and notice I put a subscript. That tells me that's the line 1, okay? That equals y2 is 4 minus y1 is 0 over, okay? And then I got my change in my x's, which is x2 minus x1. All right, so the slope of my first line is 4 over 6. Now, can I reduce 4 over 6? Yes, I can. I can reduce that. That actually reduces down to 2/3. And it's positive because both the 4 and the 6 are positive. Okay, so I found the slope of line 1. I want you guys to go find the slope of line 2 and then come back and tell me what you get. Ready? And go! Okay, let's see how you did. If you said that the slope was 6 over negative 4, uh-oh, you forgot to reduce the slope, didn't you? So you can reduce the slope. The slope of line 2 is a negative 3 over 2. Okay, negative 3 over 2. Now, let's figure out, are these lines parallel, perpendicular, or neither? So, if they are parallel, they're going to have the same slope. Do they have the same slope? No. Okay, if they're perpendicular, they're going to have negative reciprocal slopes. Do they have negative reciprocal slopes? Yes, they actually do. Okay, and I can test this. Okay, first of all, 2/3 times negative 3 over 2. Does that equal negative 1? Let's see. 2 times negative 3 is a negative 6, and 2 times 3 is a positive 6, and negative 6 over 6 is negative 1. So yes, these guys have negative reciprocal slopes, right? So these guys are perpendicular. Now, guys, if your slopes are not the same, and they're not negative reciprocals, then it would be neither, okay? All right, now, I'm going to let you guys work out the rest of these during class. I know that some of you are like, yes, I love slope. Some of you, not so much. That's okay. We're going to practice it, okay? We're practicing it. And as you work through the problems, remember to ask questions when you have them, because, guys, you're going to need to be comfortable with slope before we go into section 6. Okay, that is it for 3.5. Hopefully you guys know how to use the slopes to determine if you have parallel lines, or perpendicular lines. All right, until next time, adios.